Hey guys, this is Physics for Life Science and welcome back. Today we're going to be talking about vectors and Coulomb's law in one dimension. In the next video we'll be talking about two dimensions. This topic is probably one of the most difficult topics students find in second semester physics, especially if you haven't mastered vectors on their own. So I'm going to link the video where we talk about vectors in the video. So let's begin just by stating that what we had said earlier in the previous video, Coulomb's law is a way of expressing the electromagnetic force. And notice here the key word force, right? So remember that force, as we talked earlier, is a vector. So therefore, a vector, if you remember, has magnitude and direction, right? All right. So based on that means that we can work each individual problem as a vector. So now, one thing I would like to point out before we keep on going is something that confuses many students, and it's called the principle of superposition. So principle of superposition. Now you may be wondering, what in the world is this? That sounds really complicated. And all that it means is just forces act upon each other as if there was no other force interfering. So I'm gonna do an example to show you guys what I mean by this. So suppose there's three charges, right? I'm doing this for a purpose. And then let's go with, so three charges, right? Now I'm gonna say that this one is a positive, this one is a negative, this one is a positive charge, right? So now let's call this one Q1, Q2, and Q3. Just the Q's just means the charge, and that the distance between them, so let's make a different color. The distance between Q2 and Q3 is 0.1 meters, and the distance between Q1 and Q2 is 0.2 meters. All right. So now our problem is going to center around Q3. So now force is acting on Q3. All right, so let's just do a force diagram like we have done it previously for the first semester of physics, but just for Q3. So if we make an X and Y axis, right, your axis, and then Y axis acts on the positive, right? So now let's just concentrate on Q3. So now what are the forces acting on it? So Q3 has the force, switch colors right here. It has the force of Q1 pushing away from it, right? We can just call it force of 1 exerted on 3 or 3 on 1, right? Force felt on 3 by 1, and then the reason why I put it away or to the right is because they are the same sign, so they're going to push in opposite directions, right? So this one going to push this one because of this one. And then how about with Q2? Well, Q2 is pulling it towards it, so it's going to go to the left. And that's the force of that's felt on force 3, 5, force 2. On our charge 3, force 2. And then this is a positive charge, correct? All right, so then we have our forces. So now it's just a matter of vectors. So how can we calculate the forces? Well, basing it off of our previous video, we know that the force, the electromagnetic force, is just F equals K Q1 Q2 over R squared, right? So however, here I'm going to change the notation a little bit, and I'm going to say the force of 3 felt on charge 3 by 1 is Q3 charge 1, right? So now we know that this constant is 9e to the 9. I'm gonna skip the, actually no, I'll put the units just so it makes sense and nobody's confused. Coulombs squared times, now what do we have here? I forgot to mention that the charges, let's just make them all equal to each other, and we're going to say that Q1 is equal to Q3, which is equal to Q2, Q1 equal to Q2, equal to Q3, and let's say that's 2 microcoulombs. All right, so then we're going to come back here and we're going to plug in Q3. Well, it's 2 microcoulombs. Remember that the charge always has to be in coulombs, so that would be 2 e to the negative 6 coulombs. What is Q to the, or Q1? It's 2 e to the negative 6 coulombs as well. And then what is the distance between them? Well, between Q3 and Q2, we know that it has 0.2 plus 0.1. So this total distance will be 0.3 meters. So 0.3 meters, you have to square that, and that gives us a total force of 0.4 newtons. All right. Now I'll suggest you pause the video here and make sure you put these numbers in your calculator and you get the same numbers that we're getting. Otherwise, make sure your calculator isn't making a mistake or you're doing the right order of operations. Now, using the same formula, we're going to calculate the second force. We're going to calculate force that is felt on 3 by charge 2, Q, K times Q2 times Q1 over R squared, right? Now here it's going to be again 9 e to the 9. I'm going to skip the units just because we did the same thing here. 2e to the negative 6, now 2e to the negative 6 as well, because the charges are the same. What's the distance between Q2 and Q1? Q2 and Q1 is 0.1 meters. Now if we square that, again pause the video, put these numbers in, so making sure you're getting the same numbers we're getting, it's going to be 3.6 newtons. Alright, now you may be tempted just to add them. However, remember when we did our vectors, we find that they're they're going in different directions. So now if you see F21, you see that it's going in the negative direction. So then that means this force is going to be negative. Now to find our total force exerted on that vector, on that charge, it's going to be sum of the forces for Q3 is going to be equals to force exerted by 3 on 1 plus the force exerted 2 on 1, and that turns out to be 0.4 newtons minus 3.6 newtons, giving you a total of negative 3.2 newtons. And here the negative just tells us that it's going to the left, so your answer would be 3.2 newtons to the left. That's your overall, your net force exerted on charge 3. And now I just want to point out something really quickly. Remember from our force and acceleration chapter, F equals ma. So later on in physics, you're going to be asked to find acceleration of a particle when set on a system like this. And if you know the mass, you have to find the total force acting on that specific charge and then find the acceleration based on that. So as you may have noticed, just to recap, we did each calculation individually, like the previous charge wasn't affecting it, and that's the principle of superposition. You're assuming and you're doing all your calculations as if there were only 2 charges at the moment. So for example, when we did Q3 and 1, we ignored 2, and when we did 3 and 2, we ignored 1. That's what you have to do. That's the principle of superposition when I say forces act on each other as if there were no other forces around, and then to find the net force on a charge, you have to combine them like we did here. So I know this video is kind of long and confusing, so just pause it, go over it how many times you need to. If you have any questions, further clarifications, just write down on the comments how we can help you out. Remember to like us on Facebook and follow us on our website. And good luck with your study. Let us know how we can help you.